This is pre-AP Calculus. We're in Notes section 5.6. We are looking at two different examples, each one given a table of values and trying to answer these questions that are being asked of us. So we are asked, identify the equation of any horizontal asymptotes of the graph of f of x. Give a reason for your answer. I'm going to give the reason that I need to give first, and then we'll look at the table. In order for there to be horizontal asymptotes, there has to be some place where the limit of f of x as x approaches positive or negative infinity is approaching some number. So I'm going to just go on the assumption right now that it's going to happen both left and right, which may not actually happen. Now let's look at our table. So I know this without the table. If we move left forever, so if you look at the top values, these are x values. So as we move to the left, these numbers start getting big, positive. As we move to the left forever, it looks like the y values are getting closer to 1.499, which could lead me to believe maybe they're getting closer to 1.5. Now that's a guess. You know, it could be 1499999. Based on the information that's here, I'm going to make the assumption as we're moving left, it's getting closer to 1.5. As we move to the right forever, it looks like these y values are also getting closer to 1.5. Like this might be from the left underneath of it, this might be from the right. What conclusions can I draw from this? I could say, therefore, f of x has a horizontal asymptote at y equals 1.5. Horizontal asymptote describes the end behavior of the graph. As you move left or right, what's happening to the graph? And apparently, as we move left or right, we're getting closer to something that appears to be something close to 1.5 in either direction. B, identify the equation of any vertical asymptotes of this function. Well, to identify a vertical asymptote, here's what we need. We need some kind of a limit of this function, and this is going to either approach over here positive or negative infinity. It's one or the other. And then we're going to have another limit of f of x as x approaches some number from the left or the right. And f of x is also here approaching positive or negative infinity. So if it's approaching positive or negative infinity, it means the y value doesn't exist. And if we look up here, the y value doesn't exist here, and it doesn't exist here. So that could mean one of two things. It could mean there's a hole there, could mean a vertical asymptote. If we look here, as we approach negative 0.5 from the left, these y values are getting pretty big negative. Like when we were at negative 500, it was about 1.5. Now we're at negative a half about, and it looks like this is pushing negative 250. If we approach from the right, looks like we're approaching an equally large number, but it's positive. So once again, as we approach from the left, as x is approaching negative 1/2 from the left, or 0.5 if you prefer, y is approaching this big negative number. As x approaches negative 1/2 from the right, that's here, it looks like we are approaching a big positive number. So I'm concluding that this is a vertical asymptote here, specifically at negative 1/2. And that's because as we're approaching negative 1/2 from the left and the right, it looks like we're approaching negative infinity and positive infinity. So the conclusion that I can make from this is that this function, f of x, has a vertical asymptote at x equals negative 1/2. Identify the coordinates of any holes. Well, a hole once again is going to happen when things are undefined. That's what's happening here. And the number on the left, like that's super close to the left, 1.9 is really close to 2, relatively speaking. This number is pretty close to the same number that's over here. looks like they're both equidistant from the y value of 1.6. So the conclusion that I'm making from this is that since this 2 on the left and 2 on the right from the right is approaching a similar y value, I'm thinking there's going to be a hole in this graph at 2, 1.6 approximately. Identify the coordinates and give your reason. Let me give the reason first. I can confidently say that the limit of f of x as x approaches 2 from the left looks like it's getting pretty close to 1.6. I can also say the limit of f of x as x approaches 2 from the right looks like it's also approaching 1.6. That in itself does not make a hole. If we couple that with this function evaluated at 2 does not equal 1.6. How do I know that? Because this function evaluated at 2 is undefined. Those three things together point me to the fact that f of x has a hole, or point discontinuity if you prefer, at 2 and approximately 1.6. Lastly, state the domain and range of this function. Once again, we're assuming the domain is everything except for discontinuities. That comes from the x value of vertical asymptotes, -1/2, and the x values of holes, which is 2. So we're going to go -infinity to -1/2, skip over -1/2 and go to 2, skip over 2 and go to infinity. The range, we're assuming the range is everything except for the y value of a horizontal asymptote and the y value of a hole. Here's the y value of a horizontal asymptote. Here's the y value of a hole. So they're super close to each other, vertically speaking. So we're going to go from -infinity to 1.5. We skip over 1.5 and go to 1.6. We skip over 1.6 and go to infinity. Let's check out another example. Table below shows a similar function. Oh, it tells us the equation of g of x such that the denominator is the quadratic function 2x squared minus 4x equals 6. Now when I see this, I instantly want to factor it. Not because I'm super into factoring, I'm not some weirdo, but factoring a rational function, any function for that matter, is usually helpful. And at this point, I don't know how it's helpful, but it does build my confidence to do something when a problem starts, so I factored it. Let's see what happens. What's the domain of g of x? Well, this is pretty easy to figure out, because if you look here, the y value is undefined in these two places. So let's look a little closer. I'm just going to go on a little tangent here. On the left of -1 and on the right of -1, those y values look like they're both going to -1/2. So that would lead me to conclude there's going to be a hole in the graph at -1, -1/2. Over here where it's undefined, looks like on the left it's a big negative number, and on the right it's a big positive number. That would lead me to believe there's a vertical asymptote at at x equals 3. So the domain is everything but the x values that are not included. These two are not included because there's no y value. So the domain is going to be -infinity to -1 in union with -1 to 3 in union with 3 to infinity. Does either factor in the numerator, does either factor in the denominator also exist in the numerator? Give a reason for your answer. Well, it has to happen because we believe there's a hole in this graph. So let's first discuss how we know there's a hole. The limit of g of x as x approaches -1 from the left is equivalent So the limit of g of x as x approaches -1 from the right, and we believe that's -1/2. And if we couple that with the fact that g of -1 is undefined, therefore it could not equal -1/2, this tells us there has to be point discontinuity. So the conclusion we can make, g of x has point discontinuity, specifically at x equals -1. And the conclusion we can draw from that is the factor of x plus 1 has to exist in both the numerator and denominator. Cool. C. Does either factor in the denominator not exist in the numerator? So it's basically saying, is there vertical asymptote in this? So using our limit logic, we could say the limit of g of x as x approaches 3 from the left, that's all this jazz up here, is equal to -infinity, and the limit of g of x as x approaches 3 from the right is equivalent to +infinity. So the conclusion we can draw from that, g of x has a vertical asymptote at x equals 3, and the conclusion we can draw from that is that x minus 3 is a factor in the numerator but not denominator. Cool. D. Based on the end behavior, where does g of x have a horizontal asymptote? Well, as we move left forever, and 500 negative is not forever, but it's getting, it's getting relatively large. The limit of g of x as x approaches -infinity looks like it's getting closer to, 1.98. If you look over here, it looks like it's 2.020. So maybe those are, if you split the difference, looks like they're getting closer to 2. Be reasonable to say it's approaching 2. The limit of g of x as x approaches infinity would be 2 as well. And therefore we can conclude that g of x has a horizontal asymptote at y equals 2. Last one, what must the leading coefficient of the numerator of the equation of g of x be? Explain your reasoning. Well, let's see. If we reason this out, we know there's a horizontal asymptote at y equals 2. If that's the case, the leading coefficients in the numerator and denominator have to reduce to 2. Since the denominator is a 2, the numerator is going to have to be, when I say the denominator is a 2, the leading coefficient in the denominator is a 2. So the numerator would have to be a 4 for that to simplify to 2. Let's write that down. The ratio of the lead coefficients of the numerator and denominator and let's say right now we don't know what that is. Let's just say must simplify. We know what the ratio is. To 2, and that's because g of x has a horizontal asymptote at y equals 2. Therefore, the leading coefficient of the numerator must be a 4. I don't think I made that incredibly clear. As it didn't mention the leading coefficient in the denominator was a 2. Let's see, how can I make this better? Let's say that the lead coefficient of the ratio of the lead coefficient of the numerator and denominator, let's say that's a over 2, must simplify to 2. So the lead coefficient of the numerator must be 4. And let me say here at the beginning, therefore a, lead coefficient of the numerator, must be a 4. And I think that kind of makes sense. All right, if you got any questions on any of this, let me know. And that concludes these notes, and the homework is supposed to be done as well. And that concludes the chapter, I believe.